Continue. All right, so we're going to be looking at Access Project 3. First of all, we'll be reviewing some of the things we've done, seeing what they can do for us, doing a little bit of maintenance adjustments of our database. So let's go ahead and bring up our Access Project 3 where we ended off last time. AC3 Veterinarians. Let's go ahead and open that. And we have our AC3 Veterinarians going here. And we're going to, let's first of all take a look at what we have in there, just to review what's there. If I open up my appointments table, I can see that my appointments have an appointment ID attached to them, long name for a very short field, patient that I'm referring to, their date, an appointment, their service type, and I see that their service type has multiple choices there. If I click on that, I can see I can choose multiple items. That was one of the last things we did, made a change to the design of the database so service type would list in their choices in the lookup a choice from that service type table. Now let's see, how did we do that? Let's go back to design view. And we see under the service type, under lookup, down here, clicking lookup in the properties after selecting service type, that I see that the source for my service type was another table. And these are things that the wizard did for us, but I can sort of see what the wizard left over for us was that the source of what goes into that particular field is a selection from another table in the SQL language that we don't have to learn because it's building up queries for us. I can actually click on that little ellipsis and see that the wizard built this little query for me that it has a service type table. I choose the abbreviation and the description, and that produces an output that generates the available choices in my service type. All done for us by the wizard, but we first had to build the service type table. We entered this in our new table with an abbreviation and a description. So we filled the table with our service types that we want to be available to us, and then added that using the wizard to our type of data here. And so that gave us this, when we want to choose our service type, that gave us this capability. All to say that a database designer thinks through all of this when they're setting up your database for you. When you're using it, now you have some idea what goes on in the behind the scenes when someone creates a database and you may pay them a lot of money. You can kind of have an idea that they're building data, they're modifying tables, they're building tables, and using the data that's stored in those tables to help me choose selections as I'm entering data, either in table form or in form view form. The nice thing about this particular design here is if I ever decide I want another service type, all I have to do is come over here to my service type table and add another entry, and I have that additional service type available to me in my appointments when I choose this. So it's pretty handy that, well, let's just do that for fun. Let's go ahead and add a service type, just make up something, T-15, to add to my service type table, and I'll call that what should we call it? What kind of a treatment would it be? How about a COVID shot? We have to give them to our pets now. I added that to my service type. I close the table. And now let's see, does that show up as a choice? Oh, it looks like it doesn't show up as a choice. Maybe I have to close this and reopen it. Let's try closing and go back to my appointments. Let's see if it knows the service type. There it is. Now it shows up. I have to close my appointments. It had to reevaluate what's available. And there's my additional service type available for me when I'm setting up an appointment. So that's something we did as we were updating the design of our database. Okay, what's next? Well, now we want to run queries on our... Are we doing queries? I think... Oh, no, we're not going to do queries yet. We're going to look at another table. We don't even have to use a query for this. We're going to open up another table. Oh, I forgot. We are going to write a query. I remember this now. All right, get back to this. We are going to do a query on the appointments now. Let's go to... Get my page up correctly in my textbook here. I guess it's not a query. I forget now. It's actually a modification to our appointment table. Appointment table. Let's go to design of our appointment table. No, that wasn't. It is a query. Let's see. Messed up where I was doing my queries. Let's look at our queries on the appointments table. Let's do this now. Query, create, query design, appointments table. And we want to view in our appointments table the appointment ID, the patient, the appointment date and time, the service type, and let's go veterinarian. Okay, let's see what we get here. I'll get appointments, multiple services on a particular appointment time. Okay, all nicey, but one problem we have here is, suppose I want to have each of these services listed so someone can check off that that service was completed. Right now, it's all packed into one line. Watch what I can do here, back in design view of this query. I can add service type. After service type, I can type dot value after the name up there at the top. If I type dot value there, watch what happens. I go to datasheet view, and now each appointment and each service is listed on a separate line. One little tweak. All I did was add the dot value there after service type, and now each value lists on a separate row. Again, just to show you that as we properly design our tables, put the data in there, data can be extracted in multiple ways if you just know how to work with your database. So let's save this as a new query, how we can view our multi-value field on separate rows. So I'm going to do a Control S, and let's call this AC3-30. Can't tell that number. 35, I think. AC3-35. I'll call it multi-value field on separate lines. So giving you a taste of what the database designers do, that you can do this kind of thing with Access and have decent databases that will work for databases with hundreds of records, maybe a little slow for thousands of records. That's why they pay money for more expensive databases as they have larger amounts of data. But Access works great for small databases, small personal databases, and knowing database, even the concepts around them, will make you a valuable employee, even if you're not the one designing databases. You will always be someone, you will be at somewhere in your life be entering data into database tables, either through directly into the table or data entry through a form. All right, now we got a little more to do here with some queries and things. they do show in the book that you can change the look of your tables, modifying rows and columns. I'm not going to worry about that. And I don't even care about that particular table. Don't worry about, but know that you can adjust the look of these if you'd like to view your data. I imported some disease data just for fun into my database. You can adjust the view of grid lines and all sorts of colors. I think that's trivial. We want to do something more critical to the work of our business. We built a query with multi-value fields. And then we come to an important concept. Going to introduce you to this concept by looking at our little patients table. Our patients have three patients. C1, C2, F1 are the patient ID. They refer to owners, O2, O1, and O1. So owner 2 has 2 pets registered in our database. We look at our owners table. We see that we have O1, O2, O3, O4 possible owners. No patients yet registered with owners 3 and 4. But suppose someone comes along and is looking at Fluffy's data and sees that owner 1, oh, perhaps they view that and they accidentally type owner-11. They double click on the 1, and now Fluffy is owned by owner 11. Okay, that's in our database. We're looking through our list of pets. We go to our patients, and we need to contact their owners because we're moving. We decided to move our laboratory, our kennel, our facility. And we contact our owners. O2 and O1 get a contact. Yes, we've moved, come to our new location. Oh, here's our new phone number if you want to contact us. And we look for owner 11. Well, let's see. Owner 11 doesn't exist. Uh-oh, we don't know how to contact Fluffy's owner because we have the incorrect owner listed here, and it allowed us to enter incorrect data. Because Fluffy no longer has a known owner in our database, Fluffy is sent off to the coat factory. Gonna make a nice cat coat. And then owner 1 comes back and says, hey, I have my dog Ranger, but where'd Fluffy go? And you say, well, Fluffy's not here anymore. Someone entered bad data into our database. Sorry. Here's a cat looks just like Fluffy. No, that's not going to make them happy. You lost Fluffy because it allowed us to enter a non-existent owner, a horrible thing in a database. We don't want to let that happen to poor Fluffy. Let's fix that owner to be the proper owner, and let's not allow that to happen anymore. Here's how we do this. First of all, we need to close our tables because we're going to make a very critical change to our database, and you can't make the change when the tables are open. Now we're going to go to our database tools and our relationships designer. Database tools, relationships. Now we have some appointments and service types in here in our relationship. This tells us that when we're referring to a service type, it's going to exist in the service type table. That was done for us when we created that lookup field. We need to add more relationships. So let's view our tables. Let's see here. We need to add tables. Let's add the patients table to our database design by double-clicking on patients. Let's also add owners to our patients table, to our relationships table. And now we're going to establish this relationship. So I added patients, I added owners to relationships. I can always close if I'm not done with that. I can always close that relationships, saving changes, and I can always come back to database tools relationships whenever I want to. The tables are sitting there with no relationships established. Here's how we establish the relationship now between these two tables. I view them, add them in my database relationship tool, and patient ID is being referred to, the owner ID is being referred to here. I need to establish that link. Just like we did when we established that join in queries, I can just click and drag owner ID from one table to the owner ID on the other table. They must be the same data type or this won't work. Here's the important thing. I am clicking on enforce referential integrity. That means when I refer to an owner, that owner must exist or I am violating the rules. It will not let me enter that data. So I click create, and if there is a violation of the data right now, it will not allow me to enforce referential integrity. It'll say, sorry, your data violates the rule, you must fix it first. So that's one thing about referential integrity. Before you can establish it, like before entering data, this should have been established. Now let's see what happens when I'll close this, saving the changes. Close saving changes. Now let's see what happens in the patients table if I accidentally try to refer to owner O-11 for Fluffy. It'll let me enter it now, but if I try to leave that row or close the table, it'll say, sorry, there is a related record required in the table owners. It will not allow me to make Fluffy an orphan by accidentally entering incorrect owner. That's what referential integrity is doing for me. And this is something that someone that sends you a database should have designed into it, that you can't enter bad data. So if someone sells you a database or you find a database where it allows you to have orphaned records, in this case, a patient that is referring to a non-existent owner, that means that database has not been properly designed. It has a flaw in it and will cause you to lose records. This is something that can happen with databases if it's not designed properly. Now, I'm not expecting most of you to be a database designer, but when you're working with a database and you see that, hey, it's letting me put in the wrong state name, or people are entering data and at our website they're giving fake zip codes that don't work or phone numbers that don't work. Is there a way in the design to ensure that they don't enter incorrect data? You've seen that on websites where you go to a website and you're entering your information. You have to choose from a list of the 50 states. You can't just type in your state. It's annoying, but it makes sure that someone doesn't enter a non-existent state in the records because they value that information. And having bad information, they can't spam you with all that mail. They make sure you enter a valid email. They sometimes even have to validate that email before they let you be done. That actually is an email that actually has an email box to go with it. Same thing happening here. We establish referential integrity in the relationship between patients and owners. Let's go do some more of that. Back to our database tools, relationships, and let's bring in the appointments table. That brings in a lot of the relationships. So let's first of all show our appointments table. And our appointments table is referring to a lot of other tables. That's like a central table to all of them. It's referring to a patient, it's referring to service types, it's referring to a treatment number, and a veterinarian. Those are all items in other tables. So here's what we need to do now. We need to establish those relationships here in our relationships tools. So we already have the patients table here. Let's make the relationship between the patients in the appointments table. Actually, I'm going to delete this appointments table. I realize I have appointments table here. I'm going to establish patient ID is referring to patient over here in the patients table. I don't need appointments table listed twice. And enforce referential integrity. Yes, they can't have a non-existent patient when I'm establishing appointment. I can't accidentally type the wrong patient ID. And I click create, and now that relationship is established. When they refer to a patient here, it's referring to the primary key in the patients table. Let's do another one. The service type. Oh, they already have that. Service type is referring to a service abbreviation. in the service type table. We'll leave that one alone since the wizard did that one for us. If we try to establish referential integrity, let's see what happens. Oh, it wouldn't let us do that because the wizard didn't give us the correct table design. So we'll leave off enforce referential integrity for that one. Let's establish a treatment number. Oh, we need to get our treatment table, add the treatment cost table, because that contains our treatment number, and make that relationship. Treatment number is referring to a treatment in our cost table, and it won't be allowed to be entered if it's not listed in the treatment cost table. And this is where, again, it would come up in your future job there, where you have some information in a system that has a database in it. It's generating reports and giving some bad data in the reports. Like it's giving customers, but they're missing their email address, and your job was to email your customers about some important information. Well, you would talk to the database designer and you'd say, don't you have some requirements that either the email is a required field and it must be a valid email? Can you update the database so we have that requirement, that relationship between the data? Or when they're referring to a employee in the human resources, we need to make sure that we don't accidentally put bad data there. Is there referential integrity established between the paycheck, or the amount of pay, or the salary table, and the employees, so they get the proper salary? Let's see, there's another one here. We're referring to a veterinarian. That is referring to a veterinarian over in the, guess what? The veterinarians table. So let's bring the veterinarians table over into our relationships. And this is allowing us then, now we establish veterinarian, we know it's referring to the veterinarian's ID in the veterinarians table. Drag veterinarian over to veterinarian ID and enforce referential integrity. We can only refer to veterinarians that are in our table, otherwise our data doesn't make any sense. We refer to a veterinarian we have no information about. This brings up another thing here, that in the design, it would have been better for them to name this field veterinarian ID to make it a little more obvious that this is referring to an ID, the primary key in the veterinarians table. They don't have to have the same name, but it makes it easier for someone looking at the design to know that, oh yeah, that's referring to an ID of a veterinarian, and I can always double click on that line and enforce referential integrity. Now you can also do this, check the cascade update. If I change a field, it will update it in another table. I can do the cascade update related fields or cascade delete. You can check those, and so if you ever do delete an item, it will delete it out of the other tables. But if you ever want to modify your relationship, just select the line and edit it. You can adjust your referential integrity and additional options. I like at least choosing that one. The cascade update delete, a little more complex, but you have that option as well. Remember, if it doesn't work, it won't let you establish it. It'll say, sorry, there is, like if you had an owner-11, you already have an orphan data, it will not let you do this if you have bad data. You have to go fix your data before you can enforce referential integrity. So it's a good idea to have this enforced before we enter data into our table, because this helps make sure the data is pure as it's going in. And if it's not pure, if we have orphan data, this will break until I fix it manually. Okay, so relationships, we can always close and come back to them by going to Database Tools, Relationships. And let's see, is there any other relationships we're missing? Let's see, vendors. Let's see, our vendors table just has vendors by ID and what they supply. We don't have a vendor referred to yet in any of our other tables. It might make sense to put that in our maybe perhaps our treatment cost table, where we have the treatment, but that's left to our next level of database design of how do we add vendors? It seems to make sense that we would add vendors to our treatment costs. So I'm going to close the relationships. Remember, it's always good to close things when you're done with them. Now let's see the effect of those relationships. If I open up my let's try the owners table. I see little pluses next to my fields, my records now. Because of those relationships, I can see all the patients owned by owner O-1, Ted's patients. And in the patients, if I click on the plus, I can see what appointments that patient has. And I can see what appointments Fluffy has. I can drill down into the data because now I've established relationships between multiple tables. It gives me more information. Of course, it can be confusing on how I can expand these fields. It's like what's going on as I expand them, but it gives you more levels of information and how it's related to one another. And of course, I can always go back and just view those tables alone and see the appointments. There's my low-level table that's relating everything. Higher level tables, they have the little plus showing, hey, there's other related data that because of relationships, I can now see that in the datasheet view. So it's giving me a better view of the data, more details for each patient here. And because of the relationship over in Database Tools Relationships, I have those connections established and my database just works better for me. So establishing those relationships is key to making this all work. Now, let's go back to owners. And let's see, if I have owners, I have patients. If I change the owner's name, let's see what happens. I change owner 1 now to owner 11. Owner 11 is changed. Let's see. Oh, it doesn't allow that because the patients is referring to owner O-1. It won't let me make that change. That's where the referential integrity comes in. It won't let me leave that unless I undo that. See, I come back and see I had changed it back to O-1. If I try to change it and go to another record, it gives me that message. That's the effect of establishing that referential integrity. Let's see if we can fix that. Oh, and it won't let me leave that table unless I either say cancel or Control-Z undo my change. If I just say close it without making the changes, I'm fine. Let's go back to Database Tools, Relationships. And in the owners table, owners and patients, let's try to do cascade update related fields. And click OK. And see what happens now. If I go to owners and now try to change an owner's name, it lets me make that change now. Close the owners table and now go to patients table. And look at that. The owner got changed to O-11 because of the cascade update. So I can change the name of my owner. Let's see if I can change the name of the owner here. No, it won't let me because I have to make the owner change in the owners table. I can't make the owner change here. So I can undo that change before it'll let me go. But in the owners table, because it's cascade update, I can change my owner ID now and it will make sure all the other tables get the change applied to them. See how it automatically did the cascade update. There's the effect of the cascade update. I can change my owner's ID and not break things. Where without that, I could change owner to owner 11, it wouldn't care. Or I could change it to owner 11 here and make the Fluffy an orphan and it wouldn't care. But establishing that relationship keeps Fluffy from being sent to the coat factory. Let's see what else we're doing in our database. I think we're getting close to what we need to do here. Checking that we have all our tables listed. They did the owners and patients. And they explain in the book the effect of the referential integrity. Okay, let's go back now and let's check our tables to make sure we have the proper data entry. Let's go to our owners table, and I see on each column I can choose characteristics of that field. If I choose the owner ID column, I see that that is a very important field. It's required and unique. In design view, I can also see that if I click on owner ID, that down here it shows required, and it is a primary key that makes it unique. Now in the book they like viewing design view because that gives you a lot more properties to view. Let's go to first name. Let's see here. Should an owner's first name be required? Right now it says no. Let's make owner's first name required by choosing yes, or double clicking and toggling to yes. Remember, I can do the same thing over here in datasheet view by going over to each field and clicking here to check whether it's required or not. Something like required, it might be easier to do here in the datasheet view to say, oh yeah, that should be a required column. But you can also do that in design view by checking required there. I think for required, I'm just going to use datasheet view and table fields and go one by one through this. Owner, last name. So basically we're saying here there must be something entered in owner first and last name. Now there's no validation on first and last name because what are the rules there? Well, I suppose you could say, well, the length ought to be more than one letter. Well, maybe people want to just use their initials or something. So validation rules can get pretty complicated. Owner, street, and city and state, well, should we require that if we already have their phone number or email? Some may only have a phone number. They don't have a mailing address or only a P.O. box. Well, you can see how validation rules or requirements could be getting pretty complicated. And that's what we leave to the database programmers, that they say, well, it has to either have the mobile phone or a home phone or address, city, state, or an email. We want to be able to contact them one way or another. That would be a more complex validation rule. We could just say, well, email address, we could say, okay, it's not required. Let's just say they have to have a main phone. Maybe to change that to main phone rather than home phone and make that required. Let's go ahead and make the home phone required and mobile phone optional, just by checking that required field. Now remember, we're making this required. I can even make email address required, even though some, let's see what happens. If I try to make that required, even though some don't have an email, look what it'll say. Sorry, making that required means these two will fail that, so maybe I don't want to do that because making it required validates that. I think it will let me make it required but show that, hey, these two fields violate the rules. They're missing their email address. So changing the structure sometimes pops up those scary messages of, hey, your current data, you're missing data, and you're saying to make it required. Will that be a problem? So I'm going to uncheck it and save the owners table. So I might have to say, well, let's enter an email address, and then from now on, make it required so they don't accidentally enter data without it. So all this can be done in datasheet view or design view. I can select each element in my table, choose whether it's required or not. Let's see. Let's check our other validation rules here. I think we had a validation rule on some of those service types. The other ones, we don't have anything except, hey, it's a required field. Validation rules, is there any validation rule on a name? That's pretty much, we allow anything for a name. Email addresses, that's where validation rules can get fairly complex, and we'd talk to some expert in validation rules to find out what is a way to verify that they have entered a valid looking email address. And that can get pretty complex. We'll leave that to the experts to give us a validation rule for email. We could at least limit the field size or require a field size. And let's check our treatment cost table. We have, let's see here, that's not the one. It was vendors, yeah. In the vendors table, we want to at least make sure that we have perhaps some default values. Right now, we have quantity. Looks like the default values for quantity is 50. How about let's make the default quantity 1. How do we do that? Well, we go to design view of our veterinary vendors table and go down to the quantity, and let's make the default value, instead of 0, let's make the default value 1. As they're entering some product, there will be at least one item. Notice we do have a validation rule that it must be greater than or equal to 0, can't be a negative number, or less than or equal to 1,000. We don't have enough room for more than 1,000 of whatever thing. We also changed it from an integer to a single precision number with 2 decimal places. For the cost, let's see. Default value, how about let's put the default value of 1 for the cost. And that is set up to be a type currency. And we are calculating our total cost by multiplying quantity times cost. That was something we already had done. I'm going to put in here in the comments calculated every time the cost or quantity changes. Very much like your Excel tables, that if you change something that's involved in another formula, that formula will immediately update. So let's now view our veterinary vendors table. Now remember, anything in the description, that's just handy for someone else reading through our database to know what's in there and how it's organized. And good databases, they'll have meaningful comments all along the way. Back in datasheet view, saving my changes, I can see my quantity and cost. But you know what? It sure would be nice to know my total quantity times cost and then sum up everything and get a cost of inventory. How could I do that? There is this little item right up here in datasheet view. I can click and turn on the ability to show totals in a row here at the bottom. It adds a little row here, and I can come click under the total cost field, click my selector, and I can have it calculate the sum of the costs in that column. Does it remind you a little bit of our Excel formulas available in the quick select? Here I can calculate the sum of my costs, giving me total cost and inventory. As I enter data into my table, I can always see my total of that particular column. Now that I show totals, I can actually give totals of these other columns, even though it doesn't mean a whole lot. I suppose I could give me the average cost. And how about here? I can show the average quantity. Not sure that's terribly meaningful, but just by toggling totals on and off, I can calculate something. I don't know what that number is unless I click on it and I see, oh yeah, that means the average. Here I'm calculating, oh, that's the average there. Here I can see the calculation is the sum of those. Can I do a calculation here? What can I get? Let's see. Underneath product type, oh, since it's not a number, it can't give me a mathematical formula, but it can count how many have something in there. And sometimes the count of how many product types are listed might be useful to us. And how many veterinarian supplies I have. I can do a count of those, and they show up in that total row. And remember how I get that total row to show up? I simply choose this little totals icon up here, turning on or off the total row. Even if I turn it off, it remembers what I had set there as a total. If I want to change that, total row on, I can choose what the total is giving me, what function I'm getting. Some make sense. Perhaps someone say, no, I need to know what is the maximum total cost of the row. But let's go with sum for that one. The sum of my total costs gives me my total value in inventory every time I make any changes to quantity of cost of anything in my veterinary vendors table. So this could be very valuable. Perhaps someone's calculating it in an Excel spreadsheet. You can say, wait a minute, let's just go right to our database. It can do our totals for us, and let's see if the numbers match, if you're reading my database properly. And you can just imagine out there with databases full of millions of records, trying to do this kind of thing in an Excel spreadsheet when there's relationships between multiple tables, it can just blow up and be very difficult to do. Some very smart person might make it work, but databases make it much more efficient. So what have we done so far then? We've entered data into our various tables, related our tables, going to database tool relationships, dragging and dropping elements from between one table to another, make sure that the data is properly referencing other pieces of data that are important in their relationships, establishing referential integrity by turning on that little check mark after the relationship has been established, so we don't have orphan pets, and we don't refer to a treatment that doesn't exist. Without enforcing referential integrity, it says, okay, they're related, but if you enter bad data, you'll get bad reports. This makes sure that we don't report on data that's not there in the table, or missing important information like the salary for that very important person working for us, because the database doesn't allow us to enter data without entering important information that is related to other pieces. So there's your relationships, and of course we can always come back and view our relationships to understand how our database is working. People working with databases use this all the time as they sit and say, is our database working correctly? Is the data properly related? Are we working efficiently? And with that, let's see, I think we are done with Access Project 3. Yeah. Access Project 3 is now done. We know how to relate tables, entering data. We will be continuing this week. We'll be working with a very important database, building queries, and practicing on a different database. But for now, we have established a database for veterinarians for our veterinary facility, keeping track of the vendors that are supplying us, keeping track of owners and how they're related to their patients, all very efficiently by putting it in a database. Probably the appointments table is the most important one. We know what work we have to do as we come in each day, what appointments are available, and there's so much more that could be done if we're working for a particular a real veterinarian, but they would be using that database and paying the database designer to properly design their database as they use it. So if you like database skills, you understand this, you can converse with the database designers or maybe be one yourself. All right, save that AC3. You can upload it to Schoology, and you are done for today. And realize I had a typo. Integrity. Is that the right spelling? Maybe I did have it right. I did have it spelled right. It's just a little weird.